Assalamualaikum warahmatullahi wabarakatuh. Now let us continue with welding part 3. As I've already introduced in the previous lecture about welding, so we have two types of welding, which are fusion and solid state welding. So under fusion, we're going to cover four types of fusion welding, which are arc welding, resistant welding, oxy-fuel gas welding, and electron beam welding. And for solid state, there will be diffusion, friction, and ultrasonic vibration welding. Okay, so today we're going to go for arc welding and resistant welding first. So what is arc welding? Arc welding is a fusion welding process where coalescence of the metal is achieved by the heat from the electric arc between the electrode and the work. So the electric energy usually around 10,000 Fahrenheit or around 5,500 degrees Celsius, which is hot enough to melt any metal. So for example, if you look into melting point for aluminium, is around 600 something only, right? So 5,500 degrees Celsius is very high energy. Okay, so most of the arc welding process add filler metal to increase volume and strength of the weld joint. The most important element in the arc welding will be the electric arc. So electric arc is a discharge of electric current across a gap in the circuit. So this electric arc is the one that give the energy in the arc welding process. So it's sustained by an ionized column of gas, which is in term of plasma, through which the current will flow. So this one, to initiate the arc welding, to initiate the arc in the arc welding, electrode usually is brought in contact with the work and then quickly separated from it by a short distance. Okay, so if you remember the arc welding process that you already did in the workshop process, so that's how the electric arc is performed. When first you touch the electrode to the work material and then put a distance, a little bit of distance from the electrode here, from the work material, the pull of molten metal from this filler will start to melt, and also will start to form near the electrode tips. So as electrode is moved along the joint, the molten metal pool will solidify in the surface here. Okay, let's see the process in term of give picture here. So this is how the arc welding happen. So if we see the slow motion part here, so if you can see, there are molten metal coming out here, and then it come in pulse. Okay, so that's how the molten metal added into the pool on the surface that to be weld. There are some problem with the manual arc welding. So weld joint quality and also the productivity of the welding process is dependent on the worker skill and also the work ethic of the worker. So if the worker is not skilled enough, then, or the work ethic is not good, then it will shown on the productivity and also the joint quality. So uptime is calculated by using the equation time of arc is on per hour work by the worker. So this also known as arc on time. So for manual arc welding, usually only 20% of the time is used for the arc welding. The other are due to the frequent rest and other things. As for machine welding arc time, it's around 50%, so it's a little bit increased because of course as machine they don't really need rest like the worker. So now let us see two basic type of arc welding electrodes. They are consumable, which is consumed during the welding process, and another one is non-consumable, which is not consumed during the welding process. For consumable, it becomes the source of filler metal in the arc welding, and for non-consumable, filler metal must be added to separate it separately if it is added. So for consumable electrodes, there are two form of the consumable electrode. One is welding rod, or we call it stick, 9 to 11 inches in long and 3 over 8 inch diameter or less, and must be charged frequently. So for another one is weld wire. So it can be continuously fed from a spool with long length of wire, avoiding the frequent interruption. So if you using a welding rod, once it's finished, you have to change again and use the new one. But if you use the weld wire, it can be done continuously. So in both rod and wire form, electrode is consumed by the arc and added to weld joint as filler metal. For non-consumable electrode, the material usually made by tungsten to resist the melting, and but during the process it will gradually depleted during the welding process due to the vaporization. So any filler metal must be supplied by the separate wire fed into the weld pool. Some example of consumable electrode arc welding process. There are shielding metal arc welding, gas metal arc welding, plug core arc welding, electro gas welding, and submerged arc welding. So this is just example. There are a lot more of the arc welding type. Non-consumable electrode process. There are gas tungsten arc welding, plasma arc welding, stud welding, and carbon arc welding. Okay, so if you want to know more about this process, you might search in the books or through the internet. There are a lot of processes involved. Okay, here are some example on how the arc welding is performed by the welder. So if you can see on the first picture is showing the people using the consumable electrodes to join the pipes here. Okay, so it can also be performed using the filler. If you can see, the welder is um, holding the filler in the hand. Okay, so and this one is also consumable. Okay, it's the same like the first one. So for power source in the arc welding, of course, as you know, electric supply, they have two type, right? One is the direct current, another one is alternating current, or DC or AC. So for AC machine, it is less expensive for the arc welding. Um, and it also easy to operate, but generally restricted to ferrous metal only. So for DC equipment, it can be used for all metal, and it generally noted for the better arc control. In the arc welding, as we mentioned, the power is coming from the uh, electric arc, right? So from the electric. So in order to calculate the power, it is calculated by P equal to IE, where I is the current and E is the voltage. Okay, so this power is converted into heat, but not all of the heat will be transferred to the surface, as I mentioned in the previous class. So there'll be convection, conduction, radiation, and spatter for losses that reduce the amount of usable heat. So the effect of the losses is expressed by the heat transfer factor, which is F1, and some representative value of F1 for several arc welding process are given in table. So here is the example on how the heat losses in terms of the radiation. So for example, if you supply the heat, and then some of them will lose in terms of radiation, and it can also lose in terms of the convection, and it also loss in terms of the conduction. Here is table 30.1, which show the typical heat transfer factor. For sheet metal arc welding is around 0.9, gas metal arc welding 0.9, flat core arc welding also 0.9, submerged arc welding 0.95, and for gas tungsten arc welding is the lowest, which is at 0.7. So the power balance in arc welding is given by RHW equal to F1, F2. If you remember previously, the rate is we call RH, right? So as for this one, we calculated by using using the current and also the voltage. So we replace it by IE equal to the UMAWV. So the last part is still the same. So let's see some problem on the arc welding. So a sheet metal arc welding operation is performed on low carbon steel plate of a voltage 25 volt and current 200 amp. The heat transfer factor 0.9 and melting factor is 0.75. Melting factor of carbon steel is melting point, which is the temperature. The melting temperature of carbon steel is 1760 K. So using the SI unit, determine rate of heat generation at the weld and also volume rate at metal welded. So rate of heat generation, you know that RHW equal to F1 F2 EI, okay, or UM AV, right? So right now, since we already been given F1, F2, E and I, so we can just put all the values inside the equation here. Okay, since the value here already given, so this one is E, this one is I, this one is F1, this one is F2, right? So you'll get the value. Let's say for this one, it's become the T3375 joule per second. So now B, what they want is volume rate of metal welded. So this one, since we already been given the melting temperature, so as this one they put the table here, but the value, since I didn't provide the table, so I just put the value here. So Tm equal to 1760 K. So now what you have to calculate right now is the UM, right? So UM equal to KTM squared. So then by using this one, you will get the UM 10.3 joule per mm cube. So if we divide this one, 3375 joule per second, divide by the unit energy, you will get the value 327.7 mm cube per second. Why? Do you still remember the equation here? RHW equal to the UM AV, right? So this one, it will become the volume. Okay, so since we already have the UM, so this one is the volume. So just RHW divide by the UM, right? So you will get the volume rate. There is another problem. So in terms of the calculation, it's still using the same equations. So try to solve the problem. If you have any problem, you can ask me. Okay, so you will not be able to understand unless you try to understand the question and also how to solve the problem by yourself. If you still don't understand, you can always ask me. Okay, there's another one problem also. This one also with solution. You try and give it a try. So if you have any problem, then you can ask me. So this one is a little bit easier compared to the previous one, so maybe you want to try with this one first. So after you already tried the other two which have the solution, try to solve this yourself. So this one is as a practice, so that when it is the exam, you will be able to understand how to solve the problem. When it is arc welding operation, it is subject to high temperature, right? So the metal being joined usually will be chemically reactive to the oxygen, nitrogen, and hydrogen in the air. So the mechanical properties of the weld joint can be seriously degraded by this reaction. So due to that, some of the shear need to be created in the arc, okay, so that it can protect the weld joint. Shielding is accomplished by two methods. One is by blanket of gas and another one is by flux, or sometimes both method can be used simultaneously. So this one is to inhibit exposure of the weld metal to the air. So the common shielding gases are argon and helium, because both type of the gases are inert, so there is no reaction with the metal. And then in the welding of ferrous metal with certain arc welding process, oxygen and carbon dioxide are used. Okay, so usually it's combination with argon and helium to produce an oxidizing atmosphere, or to control the weld shape. What is flux? So flux is a substance that prevents formation of the oxides and other contaminants in the welding. So or dissolve them and facilitate removal. So it in a simple way we can say it provide protection atmosphere for the welding, and it can also stabilize the arc and also reduce spattering. Flux can be applied in multiple methods. Okay, among all, pouring granular flux onto the welding operation is one of the process where you can just pour the granular flux during the process, or stick electrode coated with the flux. This is the most common one, where the stick of the electrode that consumable is coated with the flux material that melt during welding to cover the operation. Okay, and the last one is tubular electrode, where the flux is contained in the core and released as electrode is consumed. Okay, so to make it easier for you to understand, for the first method is pouring the flux into the pool process. So for example, there are flux here, the granular. Okay, so what you have to do is just pour this flux into this area of operation. The second one, this filler metal. Okay, so this one, because this is non-consumable, so for example, if this is a stick that is consumable, so this part, um, the metal is inside here, but the outer layer is the of the this electrode are the flux. Okay, so and the last one, you can also supply this one through, let's say, this area is going inside here. So as for this electrode, if this kind of flux to be supplied to the area, the electrode will have the hole in the middle here. So meaning that during the process, flux will be supplied in the center here, so that it can come out in this area, okay, during the process of welding. So you can refer to this video links for extra understanding. Okay, that's the end for welding part 3. So we're going to look into part 4.